And so this is just, this was in your book, and I know you guys never read your book, so I like to just give you the quote out of it. But derivatives is the differential part of calculus. That's this semester. Next semester we'll do integral calculus, which is integrating, which is like undoing derivatives. It's so exciting. But this is in your book. It says the derivative was a 17th century breakthrough that enabled mathematicians to unlock the secrets of planetary motion and gravitational attraction of objects to just position over time, which is very exciting. Like, derivatives are important things, especially if you love planets. But here we go. The word derivative is a new word for us, but finding a derivative is not new to us because we've actually been doing it in chapter 2. The definition of a derivative is the slope of a curve at a given point, and we know how to do that, maybe, hopefully.
Oh, in physics, Miss Dowd asked our good teacher, Mr. Dowd, how to find the slope of the curve, and I was like, tangent line! And she was like, yes! And she acted like I did it for her class, but I was like,
It's like probably crush her hope.
Science and math, best friends.
You learn something.
So we can actually say, here's my little, look, this should not be a new idea to us, that the derivative of a function with respect to the variable x, here's the new part, the way we show a derivative is we say f prime of x. So, like, that's a little typed one, but if I was going to write this, maybe if my, no, it's like a apostrophe almost. Right? F prime of x. It's a prime. Kind of looks like a 1, but it's really not. That wasn't a very good prime. That's f prime of x. Kind of like an apostrophe. You can kind of make it a little more curved if you want. But hopefully we know from what we ended with in chapter 2 that this is how you find the slope of a curve at a point, that we can take the limit as h approaches 0 of f of x plus h minus f of x all over h. And now we can say that that equals the derivative, which we note as f prime of x. We're just changing what we're calling it. Instead of saying the slope of a curve at a point, we can now say the derivative, because that's what derivative means. You did. You already knew what a derivative was.
Does this fall in that category of multiplying the same?
Oh yeah, I got a whole list of those again for you today. I think that's the most annoying part of beginning of calculus is like all the ways that we can say it. And on your homework today, like they give you not the same problem, but the same directions. Find the slope of the curve at this point in a whole bunch of different ways, so that you can practice getting used to the notation. Because sometimes that's the hardest part of the question is knowing what it's asking. Again, notice this is only true provided the limit exists, and we're going to get into that more of when does a function not have a derivative, or when does it not have a slope at a given point, and then we'll talk about that more. Okay? But if you did okay on this part of the test, then you're good to go. If you didn't do so well, you get a little more practice today. It's fun. It's like algebra and then the calculus part of it, where you get to multiply stuff out and cancel stuff out, and then take the limit, and it doesn't get much better than that, kids. All right. Everybody okay with that? It really is. It's just new words. Maybe. And again, I kind of have lots of words for you today because it's all about understanding it. But if f prime of x exists, we say that f has a derivative. But here's a new word for you. If it has a derivative, then we say it's differentiable. What's that good word? Differentiable. Differentiable. Look, that's a good like spelling word. Differentiable. And if a function is differentiable at every point in its domain, it is a differentiable function. So differentiate is another way to say find the derivative. You know, I just know it because I've been doing calculus a very long time. Like 13 years, that's how old I am now. 13 years I've been doing calculus. I've been doing calculus.
Pretty smart for 13.
Actually, 14 years, I've known the word differentiate. But it's new to you.
Why did you decide to do that?
Because I love math.
You always like get A's and just go there. You like super.
Except for in geometry. I got a B in geometry.
You gotta be in jail.
And in college, I got a B in geometry. But other than that, I got A's. In college geometry. I had to take analytical geometry in college and college geometry, and I'm pretty sure I got a B plus in both of them in college.
Geometry, I
Oh,
suck.
right.
But I feel like maybe you don't want your math teacher to get A's, but I feel like it's good that your math teacher get A's. You say no to that. I really loved math in high school, and then like, what job do you really just get to sit and do math problems? Really, only a math teacher. You don't really just get to sit and do math problems. I mean, in college you do, but like when you get to the real job, you mostly use like computer and I mean you do some math, but what other problems? What other job do I get to sit and do the derivative of x cubed? Only math teacher.
Yeah, exactly. Which is why we have Fernandez as one of the
Because I like to torture you.
Yeah, the only job where we're gonna get this teacher.
It's the only job you're going to do it every day. How about that? So if I'm going to find the derivative of this, yes, but we're not there yet. That's chapter 3. We get to applications of derivatives, and when we get there, you'll be. Oh, just kidding. I mean, chapter 4. Keep forgetting that chapter 2 is the first chapter we do. The chapter 1's all review. Chapter 4. I think we only do chapter 3 and chapter 4 the rest of this semester. What do you think about that?
That's
I
pretty
think
amazing.
it's gonna be great.
Usually 2 tests for each chapter, so we'll have 4 more tests.
Oh,
You
like,
know, there's upside down stuff with that.
If there is, I agree.
so like when you say 4 more tests, you mean 4 more 2-part tests, correct?
You mean like 2-day tests?
Yes.
Maybe. Yeah.
So that's like 8 tests.
No, because each test is only 100 points. 4 more 100-point tests. We only do 7 chapters this whole year. So we do chapters 2, 3, and 4 this semester, 5, 6, and 7 next semester.
So what is it? They do all 7 chapters the first semester.
That's how all colleges are. What we do here is what most colleges do, and it's a 1-semester calculus. So why is it so much better to take it in high school? Because we get a whole year to do what in college they do in 1 semester. What we spend 4 days on, you might do 2 sections in 1 day on those days that we spend 4 days. Because that's why it's better to take it in high school, even if you don't get your credit. So find the derivative. So I'm going to show my notation. F prime of x equals the limit as h approaches 0. Notice they didn't tell us what value to take the derivative of that yet, right? So we're just going to leave it as, instead of like last chapter, we used a, right? F of a plus h. Yes? On the one I just gave you, was it x instead of a that was listed? Because now we want it kind of in terms of x. So instead of using a, let's just do f of x plus h minus f of x all over h. And that way, if they don't give you a number, your answer is going to be a slope equation that already has x in it instead of having a in it. Okay, a is just that arbitrary x value. What's super fun about this problem is it's a cube. So that means that I have to take the limit as h approaches 0 of x plus h cubed minus x cubed all over h. X plus h cubed. That's going to take a little work, yes? What? It'd be really great if it's just x cubed plus h cubed, but it's really not, right? That's like x plus h times x plus h times x plus h. Oh yeah, we could do Pascal's triangle if you remember Pascal's triangle. Oh, remember that good old guy?
They start with one,
1, 1, 1,
one,
1, 2,
two,
1. That would be.
three,
This would be. Oh wow. 1, 3, 3, 1. Right?
Really? That's what it is.
Well, that would be the coefficients. And then remember, you start with this as x to the third, and this as h to the 0, and you count 1 down and 1 up. I don't think anyone's ever remembered Pascal's triangle when we do this problem. But it's great, because I could do x cubed, that's the 1, plus 3, here, I'm just going to skip here, plus 3
How do you even spell Pascal?
Pascal. Right, 1, 3, 3, 1. And remember the x starts with the highest degree and then counts down. So this is x cubed, this is x squared, this is x, this is no x. And the h counts up. So no h, and then h squared, and then h cubed. If you don't remember Pascal's triangle, you just have to FOIL a few times, right? Like you can't FOIL all three at the same time, but you could FOIL these two, and you could get x squared plus 2xh plus h squared. And then you have to multiply again by x plus h, and you just got to distribute all that. Like, it works the same way. Most times people don't remember Pascal's triangle, and so they just multiply it out. But Pascal's triangle definitely is less multiplying, I think. I think it's 1, 1, 1. And then remember, the outsides are always 1, and the sum of these numbers are the inside. So 1 on the outside, and 1 plus 1 is 2. And then 1's on the outside, 1 plus 2 is 3. 2 plus 1 is 3. You're not going to ever have anything bigger than a third power. Like, that's why I put this one on here. It's because there's one on your homework to the third power, and I wanted to remind you of it. So not that mean. Right. No. The third power, they figure you could do a third power. So that would be x plus h cubed, but then minus x cubed. Right? That's the rest of my minus f of x all over h. And then every time that we do this, we should get stuff to cancel out that doesn't have an h in it. You can factor the h out, and then you can take the limit. And so the nice thing about these is, yes, they do take a little time and a little work, but if you don't get your x's to cancel out and you're able to factor out h, then you know you've done something wrong. So it's kind of like your own check for the problem. Sometimes people get something wrong, and they just go in and make it right so it cancels out. That's not really good, but, they get the right answer. But that would cancel out. I forgot my limit part here. So I could say that this is the limit as h approaches 0. And since my x cubes cancel out, I'm going to go ahead and factor the h out of that. And I'm going to get 3x squared plus 3x h plus h squared. That's doing f of x plus h minus f of x all over h. Now we can cancel out the h's, and now we can actually take the limit. Now you can plug 0 in there, and you can tell me what the limit is, which would just be 3x squared, and the rest of this would be 0, right? 3x times 0 plus 0 squared. So we could say that the derivative of f prime of x is just 3x squared. That would be the derivative at any point on that graph. We could use this equation. So that's why we like to use x, because now if you have this answer, now I could say, what's the derivative of x cubed at 7? Well, now you can just plug 7 into this equation, and you get the slope at that point, or at 22, right? So now this works for any point on that graph for x cubed. Not that bad. Pretty much what we've just been doing, right? We just changed a to x. Oh, because we don't like it. So now, there's another derivative for equation, all right? So this is called the alternate definition of a derivative. It's another formula, and it just works out sometimes to be easier work, all right? So on your homework today, it's going to give you directions. Use this definition of a derivative, or use this alternate definition of a derivative. And notice this definition of a derivative is if they give you an actual point to find it for. So look, Sean, x equals a is that.
You want to get y over x.
X minus a. Well, because a is going to be a number. You know what I'm saying? So like this is going to be, I'll show you the next problem. But this is going to be not like the last problem where it just says find the derivative of x cubed. It's going to say find the derivative when x equals 7.
So really, that is like x into is like
It's like where a is a number.
so when you plug it, it's like plug a and x in both the same number.
Let's look at a problem.
Only because
You guys are overthinking this. You're overthinking this.
No,
Write this. Both, the original definition always works, all right? Where we do h approaches 0, always works. But this definition, if they actually tell you a point, right, don't find the general derivative at any point. Find the specific slope, right? So differentiate x cubed, like we just did, but find it at exactly 2. If you're doing that, using this formula is usually a lot less algebra. Usually. A is a number, right?
yes, but if x equals a, then x is a number.
No, because x is...
Am I wrong?
The last one we were finding the derivative in terms of x. This one we're finding the actual slope, where we should get an actual number. So all you do is you replace a with the number that you're doing this with. Just like in the other time. Notice, though, the reason that people like this definition is there's no x plus h. So you don't have to cube that whole thing out. That's where people like this better. Because now, I'm going to write this out. I'll write out my formula. I'm going to take f of x minus f of 2 all over x minus 2. Right, so I'm leaving the x. I'm replacing a with what it equals. So the x I don't change. This is just the original function, which you agree is x cubed. You agree with that? Minus, I'm going to plug 2 into the function, which is 2 cubed, which do you agree is 8? I need to write 2 cubed there. What's wrong?
I don't get why you don't plug in 2 for x if you just said x equals 2.
Well, remember before this chapter, like last chapter,
I see the problem. Like, I see what you're wanting to do, because you're saying x equals 2, so I should replace every x with 2, right? Like, that's what you're saying. Because this is giving you the point. So it's like saying, find the derivative of the point at 2 whatever, 2 f of 2, right? You agree with me on that? Like, that's when x is 2, whatever the y value is that goes with that. It would actually be, in this case, it would be at 2, 8, right? Not sure. Yes or no? Do you know what I'm saying? If x is 2, the ordered pair that goes with this specific function would be the ordered pair when x is 2, y is 8, right? What this is kind of doing is kind of think about slope equation, right? Slope, don't we do like the y is subtracted on top and the x is subtracted on the bottom? Isn't that kind of what this looks like? Like, it's not really exactly, but it's kind of like I have my y's on the top and my x's on the bottom. Yes? So a is the specific point that we're talking about, at the point 2, 8, but f of x and x is just any value, so we have to keep the x in the problem. Does that make any sense at all, what I'm saying? Right, but they're wanting to plug into this x. Like, they don't want to leave this x here. They're wanting to plug 2 in there, which means you're not actually finding, remember what we're doing here. We're taking the limit as we're getting 2 points closer and closer together, right? The 2 is the actual point that we're working on. This is like the hypothetical getting closer and closer and closer, so we have to leave it in terms of x. Does that make any more sense? Okay, that's a great plan. Just give up. Okay, I'm good. So the point is that this is less work to do. Do you agree that that's less than the last problem? That's why people like this definition. The hard part about this one is it's cubic. That's a cube minus a cube. Rachel, do you remember how to factor a cube minus a cube? We just did it in college algebra. So this is why I did this one again on your homework. Side note here, make sure you write this down. If you have a cube number minus a cube number, it is factorable. It's one of those things we learned about in Algebra 2, and very briefly we talked about in pre-calculus, but it's not used very often. It's not like a squared minus b squared that you know how to factor right away. This factors into a minus b times a squared plus ab plus b squared. Every time it factors like that. And I'll go ahead and give you the sum of 2 cubes also, a cubed plus b cubed. And that's all you do is you change the first 2 signs. So that factors into a plus b times a squared minus ab plus b squared. Again, remember that calculus just kind of figures that you know all the algebra that you've ever learned in your whole life and you have it like right there in your brain. But sometimes we don't, so I like to give you these reminders. Yes, the last one's always plus, but in minus, the first one's minus, and plus, the first one's plus, and then the other 2 alternate. That's how I always remember it. If you know that, this becomes a really easy problem to factor and simplify. Remember, I think I totally left my limit off this, didn't I? All this hubbub about x and a. We're really taking the limit as x approaches a now. X is approaching that number. So this is a whole new definition of a derivative. We're no longer h's in the problem. All right, that's what's making this different. But the idea is it's supposed to make you have less work to do. It's still a problem for us to take the limit right now, though, because I can't plug 2 in here. Right? 2 minus 2 is 0. But if I factor the top into what it factors into, x minus 2, and then it's the first one squared plus the first one times the second one, which is 2x, plus the last one squared, all over x minus 2. Right. You don't double the term. You just multiply the first times the second. And if you multiplied that back out, that you would get x cubed minus 8. This and this. Like, I always look at these two. Like, once you do your parentheses, it's the first one squared, the first one times the second one, the last one squared. Like, that's how I think about it in my head. Are cubes a huge part of this chapter? No, but it shows up today, so that's why it's in your notes today, because I knew that we usually don't remember this, so I wanted to make sure on your homework tonight, you'll have these notes to go back and look at, and you won't be freaking out about cubes. But the idea is now I could cancel this, just like with my h limits, and now I could find the limit as x approaches 2. All I'm left with is x squared plus 2x plus 4. And now it's just direct substitution. You just plug 2 in, and you get the slope. So I would get 2 squared plus 2 times 2 plus 4, or 4 plus 4 plus 4 equals 12. F prime of x, or f prime of 2. F prime of 2, or the derivative at 2 equals the limit as x approaches 2 of this function, you would just say that, equals 12. It is. I sort of probably went down to the bottom one, but that's okay. 12 is the answer that we were looking for. Could you have done this with the other function? Yes, it works out the same way, but this one usually has less work. So the idea is if you're finding the derivative at a point, then you can use this one, and you usually have less like foiling out to do because there's no x plus h quantity. All right, so I'm going to do another one in a minute, and I'll do it both ways so you can see. And except for on your homework today when it says use this one, it doesn't really matter which one you use, but I'm going to tell you, like, once you use this on your homework, you're going to see, wow, life's a lot easier with this because I don't have so much work to, like, there's not as much chance for algebra errors using this one. All right? But before we do another example, I want to give you all those lovely words that you love. All right? Take a break from the algebra. We kind of talked about this already, but if it says it's differentiable at x, that means that the derivative exists at x. No, I'm really not. I just got more here. I was just trying to look this up. Page 100, Sean, later, maybe fourth hour, you can look at this. Read about that alternate form, and maybe you can make some more sense of it. But there's a nice picture talking about a and f of a, right, and how we're using it, the same idea as the secant. Like, that's why, like, a is an exact point, f of x is the function in general. Like, it's not x equals that, it's f of x, which means it's the function itself. I don't know. I'm just telling you, look on page 100 and see if you can make sense of it. I've just never, ever, page 100, 101, it talks about the alternate form. I've just never even thought about plugging in a for x, ever. Like, it just never crossed my mind, so I don't know how to explain it any differently. It's just...
I mean, I'm going to roll with it, but by logic, you would plug in whatever you were looking to do.
Differentiable on an open interval means that the function must be differentiable at every point on that interval. And then here's the other stuff. These are the different notations. F prime of x is the one that probably I use the most, but I try to use different ones just because there are other ways to show a derivative. And on your homework today, they show different ways of doing it, and I want you to hopefully get used to seeing the other ones, and I'll do my best to show you some other ones as well. But F prime of x kind of is our favorite. But we could also just write y prime, because f of x is the same as y, right? So y prime is the same as f prime of x. They both just mean the derivative. Well, that's just like my word, and then this is just my definition. Sorry, no. It's just like my underline. This is like the vocab word. Like, different questions ask you different things. Like, on the homework today, like, one of them says, find f prime of x. One of them says, find y prime, right? And so you, like, it's kind of a lot today, but as you do it, like, it'll just become, like, second nature that you know it's derivatives. But that's why we try to use a lot of them, because they all mean derivatives. So, yes, they will ask you using all kinds of, the AP test uses all of these forms. And so we want to make sure that we get used to them. What else can we do? Think about, derivative means slope. And slope means like the change in y over the change in x. So another way that we write this is dy over dx. And d is kind of like the change in y, but we say this is the derivative of y with respect to x. But I always think about slope. Slope is y's over x's, so it's always dy over dx. That one's used quite a bit also. This one's not used so much, but it does show up. And this is just d over dx and then of f of x. That's the derivative of f at x. And notice they've really just changed y to f of x in this one. And right, like y is the same as f of x, and they've just moved the f of x down. So those are really the same. These are the ones that show up a lot. All right, there's one more that they list that I don't even really know how to say it, but I threw it in here. sometimes they do this. Capital D, I don't know if we ever see this, but it does show up occasionally. I don't really know how we say that, but it means derivative, so you know. I don't know if you really want to write that down on your notes. I'm not sure, but this one. Which one are you talking about? Yes, it's dy over dx. It's like slope, rise over run, right? So yes, it is a division sign. So on your homework today, again, pretty much all the questions are find the derivative, but they ask you using lots of different notations here. So if you get stuck today and you're like, I don't know what I'm supposed to be doing, there's a good chance you're supposed to be finding the derivative. But if you're not sure, you can ask me. I think pretty much. So let's do one more. It is a lot today. A lot of collecting numbers, simplifying, finding derivatives. So this one we're just going to do we're not even squaring, we're not cubing, just a basic one. And I'm going to do this one both ways. I'm going to do the original form of the definition with the x plus h. And then I'm going to do the alternate form so that you can see both ways and you can see that you do get the same answer. On your homework, you're never going to have to do both of them, like both types, but we're going to do both ones. All right, this is my last example. Yes, you can turn them in anytime until next Thursday. So I'm going to do the old way first. So I'm going to do the derivative at 2. I'm going to do the limit as h approaches 0 of f of 2 plus h over, minus f of 2 over h. Hard part about it is when you do both definitions, sometimes you have to think about which one you're using so you know what to put in. F of x plus h minus f of x all over h. It's really nice on this one because we don't have to FOIL anything out. We're just going to get the limit as h approaches 0 of 3 times 2 plus h minus 7. Remember, you're subtracting the whole thing here, so I'm going to put minus parenthesis 3 times 2 minus 7. Ugh, I should have went to the next line. F of 2 plus h minus f of 2. So I get 6 plus 3h minus 7. I'm going to distribute my negative, so I'm going to get minus 6 plus 7 all over h. So 6 minus 6, negative 7 plus 7. I'm left with 3h over h, or just 3. Which means I could say that the derivative at 2 equals 3. With me on that? If you don't get your numbers to cancel out, so if you cancel h out, your math is wrong, and you need to go back and fix it, because it's going to work. Alright, that works every time. But I want to do the same problem with our alternate form of the definition. Definition of derivative. Alt def of derivative. Right, because h canceled out, like there's nothing to even plug in, right? Like there was no x left to plug in, so like it was just 3. Yeah, well like the limit of 3 is 3. You see what I'm saying? Like if there's nothing to plug in, like it's just the constant. The limit of a constant is a constant, because the y value is always the same. On this one, if I was writing this out, I no longer have h. So now my limit is as x approaches this value, 2, going to take f of x minus f of 2 all over x minus 2. And again, I'm just using my function here. So f of x doesn't change. So the limit as x approaches 2 is just going to be 3x minus 7 minus f of 2. You could just plug 2 in if you want, but I always just like plug it into each one. So I would do like minus 3 times 2 minus 7 all over x minus 2. Anybody have a question of where I'm getting those numbers from? So definitely you don't have to show as much work as I did on this one, but I would get 3x minus 7 minus 6 plus 7. My 7's cancel. And notice I'm trying to plug 2 in there, which is always going to give you 0 in the bottom, so you should be able to factor the top. And on this one, I can factor a 3 out. And again, I'm just left with 3. On this problem, I would agree that both of them are about the same amount of work. If you have a squared term or a cubed term, the alternate form is so much better. You can only use the alternate form if they give you an x value to plug in, though. Like if they give you at what point you're finding the derivative. So you need to have a point to plug in on that one. If they just say find the general derivative, you got to go back to the original. Okay? And again, your homework kind of tells you which one to use. And I think there's a couple problems today talking about tangent lines again, so I just wanted to remind you, if we added to this, what if I asked you to write the tangent line for that function at that same x value? What would we need to do? What do we need for a tangent line? We need a slope. Do we have the slope? The slope is the derivative, right? The slope is the same of the derivative at 2. And what was our slope? What else do you need to write an equation for a tangent line? A point. We have the x value, right? So we know that x equals 2. Can we find the y value that goes with it? Yes. And so if you can do that part, writing the tangent line usually isn't so bad to do. I forget our point here. 3x minus 7. So I can say f of 2 equals 6 minus 7 equals negative 1. So I have my x, I have my y, I have my slope. And remember, you don't have to simplify it. I say check the back of the book, but I would say y minus negative 1 equals my slope times x minus 2. If it's an odd problem and you look at the back of the book and it's in slope-intercept form, go ahead and make it in slope-intercept form. But if it's even, it's what? You just get to leave it like that. So really, the only new thing today is that alternate form of a derivative, which is supposed to be easier, but it's kind of caused some issues today. So. No, I just don't know how to explain it. Like, to me, it makes sense that we're at a and x is the function, but I don't know how to make that make sense to you. But it just, I don't know. What's it? I'm just confused. Again, I say look on page 100 and see if you can look at their pictures and their explanation and see if it makes better sense to you. I have one right here. This is 3-1 day 1. You'll see that every section in here we're spending at least 2 days on. We'll definitely have worksheets that's thrown in here as well. Because this chapter is kind of all about getting us used to derivatives. 1 through 11 odd, 19, 38, and 39. 1 through 11 odd, make sure you check your answers in the back of the book. But there's work to show with those. Like, you're doing a limit every time, so just an answer, you know, I'm going to be on to your tactics. So. So on page 100, they take our, listen. On page 100, they take our normal little secant picture that we drew back in chapter 2, and they just relabel it using f of x and f of a. So it's the exact same thing, they just relabel it. So maybe you can look at that, and it'll make sense. I expect that you look at that